All right, let's check out 3 and 4. We'll do them both together on this one, so very related. So remember that these functions, and once again, it's hard for me not to fully explain, but for any of these, if you need more explanation, just reach out and I'm happy to give that to you. But so here we have these functions in the model of a reciprocal function, right, where we have a constant on top and we have some binomial on the bottom raised to some power, right? So really we just want to think about, okay, well, is it raised to an even or odd power? So when it's raised to an even power, that means we have a situation where the function is going up and up, right? Anything to an even power is going to be positive. And so as long as there's not a negative out front, then this will be going up in both directions, right, as we approach the asymptote. So we also want to identify the vertical asymptote, so we'll do that as well. So we'll just do it right now. So since this is x minus 7, the vertical asymptote is going to be at x equals 7, right? Because 7 is the number you could plug in for x to get a 0 in the denominator. And you can't divide by 0, so that's where you have a vertical asymptote. Okay, so that's our vertical asymptote. Okay, and as we approach that vertical asymptote, as x approaches 7, what we can see here is that since we have an even exponent, no matter what side we approach from, this will come out positive, right? And it'll be a very, very small number, like 0.00000001 or whatever, but it'll be positive. And so when we divide 1 by that positive infinitesimal, then we're going to approach infinity, right? So this limit will approach positive infinity from both sides, okay? Because this is even. All right. Now, when we have an odd here, what's going to happen is we're going to approach positive infinity on the right side, right? Because when you raise a positive to an odd power, you get a positive. But when you raise a negative to an odd power, you're going to get a negative. So we're going to have a situation where it goes down on the other side, right? And so since it's going up on one side and down on the other, this is going to be DNE, okay? All right. And so, and remember, that's always the case with a two-sided limit and an odd exponent. Okay, and here the vertical asymptote is x equals -3, right? Because that's what would create a 0 in the denominator, right? It's the opposite of this. Okay. All right. Now, one thing I didn't do is justify our answers one-sided limit. So let's do that real quickly. So for this number 3, I said it's going to go to positive infinity from both sides. So the limit as x approaches 7. I'll just do it like this and just save a little time by shorthanding. So it'll be positive infinity as we approach 7 from the left, okay? And then as we approach 7 from the right, it's also going to be positive infinity, okay? All right, and then in this one, the limit as x approaches -3 from the left is going to be negative infinity, and the limit as x approaches -3 from the right is going to be positive infinity, right? And the fact that these are different is why we have DNE as our answer here, okay? All right, so that's the justification there. Remember that if you have a negative in front, like either here or here, that flips everything upside down, right? So this would be negative infinity, and then this would be negative infinity. If you had a negative here, you'd still get a DNE for the two-sided limit, but this would be positive infinity from the left, and this would be negative infinity if you approach from the right, okay? All right, so that's that in a nutshell. Like I said, let me know if you have any other questions on that.